Are we good to go? You guys ready? Sweet. We're halfway through Ignite. You guys coping okay so far? We kind of got 5 o'clock by us. It's like, oh, I'm so tired. Is that everyone? Yeah. You know there was coffee on, right? Just get the coffee, tap the vein, inject it straight in. All right, so just so I know roughly where the room is, who's played with Docker so far? Okay. Who went, there's just nothing else for topic. We might just go here and see what the train wreck looks like. Okay, I'm watching you. Who's interested in where this is going in terms of microservices, containers, and so forth, but just hasn't really had an opportunity to explore and poke around and kick the tires yet? Okay, so this is a 300 level talk, which means I am making some assumptions around where you're at. Have you been to some Docker talks so far, by the way? Yeah, maybe Ben's talk this morning on the Windows containers. Did anyone go to that? A few of you. Who's a DevOps? That should be everyone. See what I did there? It was pretty funny. Make myself laugh. All right, so we'll go fairly quickly. There's a lot I want to cover in a short space of time, so which is pretty normal for most of my talks. If I lose you along the way, feel free to just bank your questions up and ask them at the end. I'll try and make sure there's enough time to ask all the random questions you want to ask. I might even answer some of them. So I'm Richard, as you can see. That's my Twitter handle. You can find me with my email address. The slides will be available from the Ignite stuff, so you can download the slides afterwards. So don't feel like you have to take photos of everything. If you do, I don't mind. It's not a problem. And what we're going to cover in terms of this particular talk is obviously the Docker basics, Windows containers, Linux containers, the differences between the two. What I'm going to do is I'm going to take the Nerd Dinner application. You remember Nerd Dinner, anyone? MVC application, sample app. We're going to take that and we're going to stick it in a Docker container and run it, just to show you what you can do with .NET Framework stuff. Because a lot of people go, oh, if I'm doing containers, I have to be writing everything .NET Core. You know, we don't want that. So I'll show you how to take existing code, run it in a container. Then we will talk about microservices and more the heterogeneous approach to things. So not just .NET Core, but you know, PHP and everything else. See how we can take that and deploy it. That one will be on Linux containers, just so you can see both. So obviously, Nerd Dinner will be a Windows container. We'll do then the Linux containers, and then we'll take those Linux containers and we'll deploy them to Azure using Docker in Azure as well. And we'll have a look at container service and the Azure Container Registry as well, very briefly, just so you can see what happens from the ops perspective. There will be mostly demos, maybe 50-50 actually. So we'll do a little bit of talking and then we'll crack out the laptop and see where things are at. So here's your 5 minutes or less run through of Docker. Are you ready? We have an image. We're good? Okay. So an image is basically an image of a container. Yeah, it's not a picture. No, and it's a safe for work picture. It's okay. So it's basically just files laid out in a disk on their file system. The file system that Docker uses is a thing called the Union file system, which is built on layers. We'll go through that soon. A container then is a running instance of an image. Runs in its own process space. It's a virtualized kernel. And then we take those images and just run them. We can run multiple containers using the same base image. When a container runs, it doesn't affect the image it started from. So that remains immutable. So every time I start a new container using the same image, it's always the same starting point. This is where persistence and containers becomes an issue, because if I turn that container off and I restart it, anything I had done in that container isn't saved into that base image. So when I restart, I lose my changes. There's ways around that with volume commands and so forth. We'll deal with that. The host itself is just something running containers. Fair enough. The repository stores images so that I can run them across multiple hosts. So I can have a host that connects to a repository, pulls the image down from that repository, and then runs it, which is great when you want to run lots of them. And a registry is basically for sharing those images and is backed by one or more repositories. Fairly straightforward. We then also, in recent versions of Docker, have these experimental features with Swarm called bundle and stack. A bundle is basically, as you can see, a collection of images that I might deploy. So anyone come across Docker Compose so far? Show of hands, a few people. So Compose is a way of deploying a set of containers as a discrete whole. Bundle is effectively taking those container images and putting them together like in a zip file so that I can distribute them together. So I might want to send my container collection of container images, to someone else to deploy. I bundle it. A stack is simply then a running instance of that. So very much like image is single container, image is to single container as bundle is to stack. Fair enough? All right, so that's it. That's Docker. We're done. Not quite. Probably the only other thing to consider when we're talking images is we're not deploying an application. We're deploying an application with its running environment, isolated from anything else. So when we deploy now, we don't deploy an application. We don't actually upgrade applications. What we do is we take our images, we promote those to production, and we deploy those images into various environments. And we run containers off those images. So when we say, as a developer, works on my machine, guess what? It does. And it works on their machine, and their machine, and their machine, and their machine. Should work on every machine now. Should. You can do some things to change it. You can configure your containers at runtime, but generally that works on my machine excuse should go away, because if it broke in production, you should be able to break it on the container running on your local dev machine, which is great. We also now don't have to worry about installing dependencies on my local dev machine when I'm building software. I simply take an image and I run a container. It's got all the dependencies in that, and it doesn't have to affect my dev box, which is great for those who don't want to put Java on their machine. Anyone? Yes, I know, it's like, yes, happy days. IT pros, on the other hand, don't have to worry about developers giving them MSIs and going, do I really want to install this? And then, closing their eyes as they hit the button and waiting for everything to blow up and turn into a smoking mess. And they can very much move to that cattle, not pets approach. We're not going to spend too much time there. These ones here, you can just catch up. I'll put those slides. They're available online for you to look at later. What I really want to do is just talk about Windows or Linux. Windows or Linux. So a lot of people think that containers and Docker only runs on Linux. Not true. Container technology runs on both OSs without too much drama at all. The question then really is, well, if it runs on both, which one do I use? Which one do I actually want to run? So Linux, as you can see, is definitely the more mature choice. Docker itself started in Linux land and has a few more years of active development under its belt. The approaches around that are a lot more mature. Docker on Windows is catching up. The container technology is working. There's just the environment and the ecosystem around it. The tooling on Windows platforms for Windows hosts isn't quite the same as on Linux hosts at this point in time. That will change. The main constraint around this is, should you use Windows or Linux containers, it's all going to depend on what container-based platform you want to run. Because the way virtualization of containers works is it virtualizes the kernel, the OS. So when you make in a container a kernel call, it's effectively proxying through to the host to run. It's a bit more than that, but effectively that's what it's doing. So I can't take a Linux kernel and proxy through to Windows kernel calls for obvious reasons. And similarly, I can't take a Windows container and run it on Linux because the kernels don't match. The OS architectures aren't the same. That's your number one constraint. If I'm a .NET developer, really I want to be thinking about, what framework am I running on? If I want to run full .NET framework, I'm constrained to Windows. If I need different dependencies, I'm constrained to Windows. If I have C++ libraries I'm going to p-invoke, I need Windows. Whatever else. If, on the other hand, I'm playing around with maybe .NET Core or I'm doing something else, then I can choose between them. I can go Windows if I prefer or Linux. I also have another concern. It's not just about the developers. When you're choosing the container approach, are you organizationally constrained? What are your ops team going to be able to support? Because if they can't run hosts of the target type you want, don't go there. So are you constrained by organizational policy to only have Windows servers because support? or because whatever reason. Or are your dev team just not skilled up enough in Linux to be able to run that stuff and deploy them and cluster them and deal with that in a mixed environment? I don't know. Would you be happy running on Azure Container Service? In which case, at this point in time, you're really looking at Linux containers. So these are the choices you have to make. I can't answer them for you directly. Instead, what I want to do is just show you how both of them work so that you can then go back and have a look at this yourself. So let's take and jump straight into demos. The Nerd Dinner application, we're going to Dockerize this thing. We're going to show you how to put it into a container. We're going to use a Docker file to do that. And then we're going to crack out the debugger and attach Visual Studio and show you how you can debug into a running container on Windows. Now, as I mentioned, Docker uses this thing called a union file system. When we run a Docker file, it consists of a number of steps that we execute. Each time one of those steps executes, it creates a new layer. So we start with a base layer, then we add new layers on it, more layers, more layers, more layers, and the net result, the image, is the union of all those layers. That final layer you generally tag with a name so that you can identify it. You don't have to. You could try and do it by an ID. But when you see the IDs generated, you'll want to generate tags. And we'll do that. So we're going to start off with a base OS, Windows Server Core. Why Windows Server Core? Because we need to run .NET Framework on it. Trying to run that on Nano Server, which is an option, would be a nightmare because you effectively have to configure Nano Server to have everything you need to be able to run .NET and IIS. So we'd start with Server Core, we'd add IIS, we then add ASP.NET, the .NET Framework. The good news for us is that this already exists. If you go to hub.docker.com and you search for ASP.NET, you'll find an image published by Microsoft, an official image, which is a Windows Server Core container with these things already configured. Sweet. We're going to use that as our starting point. On top of that, to run Nerd Dinner, we need a database. So we're going to install SQL 2012 local DB into that. We're also going to configure IIS. We're going to add an app pool and make sure the virtual directories are all set up. We're going to put our application code in there, and then we'll execute it. Visually, just again, so we can explain how this layering works, Windows Server Core, install IIS, add ASP.NET, then 2012 Express, and you can see these layers keep building up. Add the Nerd Dinner code, open port 8081, so I want to listen on a certain port. By default, containers, when they run, don't expose any ports. They don't listen for anything. They just run, so it's a security thing. We have to tell the container to listen on a certain port. And then on our host, if we want to access that externally, we can map a host port to the container port, which is usually, if you've seen any Docker command lines, you see like -p and then port number, port number. That's that mapping. And that's pretty much it. So I'm going to just jump straight over here to my machine and do this. So I have on here, has that come across? Excellent. You guys can see this okay? If I go Docker images, you can see that? Hopefully. Thank you for your responsiveness. It's been great. All right, Visual Studio. So I'm going to open a solution. This is the Nerd Dinner solution. All right, so this message here straight up, I don't have SQL 2012 Express on my local dev box. I didn't want to install that dependency on my machine because it will mess with the other SQL things I've got on my box. I don't want that. So I want to keep this isolated. Nice. I won't actually be able to run this code locally. I'm just going to compile it and deploy it and run it always in my container. And if you look at it, it's just normal .NET code. I'm not going to go into it. It's Nerd Dinner code. The only real changes I've made to support 2012 Express. What I'm more interested in is if I go over here and I go code Dockerfile and open VS Code, I'm going to walk through how this works. So we start off with a starting image. This is our base layer. I'm going to start with the Microsoft ASP.NET layer, and I'm going to use the version 4.6.2 one. So the general approach in terms of how containers are named is you have the publisher, the owner, / the image name, and then a colon for the version number. You'll see there's a convention for the version number to be latest, which is always just keep using the latest. I want a specific one so that as Microsoft revs it, I don't end up picking up the different versions. You'll then see I set my default shell to PowerShell. Normally it would just be command prompt, so normal DOS commands. I'm going to run PowerShell, and the first thing I do with PowerShell is invoke a web request to grab that URL there, which is easy to find. You'll all remember that one, right? And download SQL Local DB into my container. So that will put it in the file system on my container, or in my image. By the way, the trick to finding those URLs is to use your F12 tools in your browser, download it yourself and watch the redirects, and eventually you get to one of the redirects from the Microsoft.com site that looks like that, and that's the one you grab. Then I'm going to run a command prompt script, so I'm going to run command. Now, you'll see here there's two formats to the run command. There's one that's effectively just that script that's running, and it looks like a normal command, and then you've got this one with square brackets. Docker files have two different syntaxes in them. You can mix and match with these things. Normally, it will try and just parse things using spaces, but you can do other approaches. So here we're doing command, we're doing an unintended install MSI exec of the SQL Local DB MSI that I've pulled down, and I'm sticking this I accept SQL Local DB license terms, whatever, and put that on. That will actually then do the installation, paint it out onto the image, and create a new layer. Then after that, I'm starting local DB and giving it a name of V11, which is cool, exposing port 8081, and then I'm doing a few other things. After that, I'm going to remove the default website. I don't need it. Why does IIS need to be running with the default website when I'm going to have my own website anyway? I'm creating a few directories so that I can set the virtual directory up for the new website, which I'm going to call the creative name of Nerd Dinner, and set it to the .NET 4.5 app pool. This is fairly straightforward, correct? At least when you see it like this. It's easy when you've seen the solution. Nerd Dinner itself does a few other things that make it a little bit more challenging or a little bit more unusual, and that is it plays around with some HTTP handlers, so we need to open up the web config to be able to get those handlers working, so we just needed to do, down here you can see inet server app command, unlock the config. One of the key things when trying to Dockerize any application is if you need a GUI to do anything, you're effectively hosed. It's a container, there is no GUI. Windows Server Core has no GUI. The Linux containers don't have a GUI. Nano Server definitely doesn't have a GUI, so you need to be able to script everything through command lines. If you're afraid of the command line, stay away from Docker. Shouldn't be afraid of the command line. And then the other thing I'm doing right at the end is I'm copying in my published website. So I'd go into Visual Studio, I hit the publish button, I publish to a local file system. So if I go here and I go to publish, you can see I've just configured this to publish to a folder on my disk. I'm not doing anything other than bundling the site up basically so it's deployable. And then I'm Xcopy deploying that into the container effectively. Straightforward? All right, I won't actually do that. Oops, that one. That's what I want. All right, so now, if I'm going to do this, I have this Docker file. I'm good to go. I simply go docker build dot to give it some context. And I want to tag it with a name. I might call it ND2 just for fun. And this is now going to run my build. It's just going to have a little think for a moment. It's going to make sure it's not too late in the day, that it's okay to work. It takes the context of what's currently in my current folder, passes that to the Docker engine. It's then going to go and process these steps. The good thing with the Docker engine is it's not going to re-download all the SQL MSIs or anything else because I've already done that before. It should have cached layers. And you'll see in the steps there that just went through blindingly quick, that we've got, for example, the download here, that invoke web request, because it's already been executed once, Docker already knows if I start from this layer and I execute this step, I've already got this result. I don't have to go and do it again. When you do Docker files, if you've got application code as the main part of your, the most volatile part of how your app is built, always do that as your last step. Prep everything else you can before and then put your application on your container image. That way, all those pre-steps that never change, you don't have to redo them every time, because as part of doing a Docker build or doing container development in general, you want to skip all the things that are slow. I don't want to keep downloading every time a 60 meg image from the internet every time I build the container. I want to use the cache result that's already there. I don't want to wait for SQL to be reinstalled every single time I do a build. So make sure those all happen before you do the step that changes. All right. So once that's there, I now want to run this thing. Make sure the container's working. So I'm going to go Docker run. What do I call the image? I'll use the other one. So I've got a few of these images. So Docker images gives me the list of images I've built. I'm just going to run the ndebug one for fun. Oh, I should point out a few things as well, just before I do. Look at the size of the Windows Server Core image. That's nice, isn't it? 9 gig, 9.5 gig. Nano server, 925 meg. And then you look at ASP.NET, it's 10.1 gig. We're looking at my debug image and my Nerd Dinner images, release mode and debug mode. They're 11.1. So on my disk at the moment, you would think I'd have 1, 2, 3, 4, 5, 6, that's 80 gig worth of images, correct? I don't. I have maybe 12 at most. The Windows Server Core, remember, it's a union file system. Windows Server Core is a base layer. ASP.NET is built on top of that, so it only contains the differences. My Nerd Dinner ones only contain the difference on top of the ASP.NET images. So even though the net size of the layering, the union file system is 10.7 gig, we're only storing the layers, which means it's quite efficient in terms of disk space. Which is quite different from virtual machines, because in a virtual machine, yes, I would, if I had this, I'd have 80 gig worth of VM images. And of course, every time I open them, I get more space chewed up and all that sort of thing. So Docker run, what am I doing? I'm going to run, give it a name, Nerd Dinner, and let's see, I need to give it a name, so I'm going to use the nerd ndebug one, sorry. And I want to run it as a daemon, so I should have put that there before. So this will run in the background, and I fat-fingered that. And I'm already running. Am I already running? Oh, I am. Okay, so I have some old ones I left behind. So I'm just going to go Docker container prune. Yes, get rid of all those old containers and run it again. All right, so you can see it's just given me a container name. It's auto-generated. It's an exciting name. Of course, this takes a little bit to start up because Docker's got to go and spin up the Windows Server Core image, which is, as we see, about 10 gig, allocate a bit of RAM, get everything going. Once that's going, we should be set. We're just going to stare at the screen. It's very exciting, waiting for the command prompt to come back. It's happening. Let's do it. This is the point where I take a subtle drink of water. Play the elevator music. Sorry, what was that? Sure. Yes. Sorry, something about elevation? Yep. Not so much in a container. So container, the server core image in the container is different to a base Windows install. Obviously, I ran an MSI, as you saw, running the installer. I didn't elevate for that. the way Microsoft's put that image together is to make sure that, that it's easy to use in containers. They've optimized for container usage, and the expectation is that if you're doing something with a Docker file and you're setting things up, you know what you're doing in there, and you're not really worrying about other people coming in and attacking it, so forth. If you wanted, you could probably put your own things in there. You could, if you need to, you can do silly things with group policy and make sure that no one can do anything with your image. I don't know why, but you can. Oh, we're good, we're good. All right, so now, the way this works, I'm currently running way down here, as you can see, a little thing called Docker for Windows. I'm on Windows 10, and I am running Docker here. Currently in Windows containers, I could switch to Linux ones. Windows containers on Windows 10 run as Hyper-V-based containers under the hood. You don't see any of this, you don't feel it, it's how they work. At the moment, there's an issue. If I tried to hit localhost port 8081, you will see that this is a bit sad. So if I go localhost 8081, it's just going to sit there for a while and go, I don't know what you're talking about. That's a bit sad. The reason is the loopback doesn't work properly at this point in time. I'm sure they'll fix it, but at this point it doesn't. So I need to actually go and say, well, can you tell me what IP address you do listen to? So if I go docker inspect nd, it gives me details about the container as a nice set of JSON files, and I see there's one of these in here that says IP address. So I'm just going to copy that, make it easy, and pop that in here. Linux containers don't have this issue. You can just hit localhost and everything's fine. Now this is going to sit there and spin for a while because obviously ASP.NET is starting up. Fair enough. We're waiting for ASP.NET to do its thing. Come on, let's do it. Again, this is fun. Isn't this exciting? So thrilling. Any second now. Another question. Wait, no, too late. It worked. Okay, so this is Nerd Dinner, .NET MVC application with no real changes running inside a container in Docker on Windows 10, ready to go. I could take this image and deploy it to Windows Server 2016 and run it as is, and everything would be sweet. Just to prove that things are working and that things like the database are good, I'm just going to register. Go here, create a username, give it a password of something creative like, I don't know, let's see, what did I just type? Oh yeah, that's a good password. Password 1 and register, and we're up and going. You can see up the top right here, hello A, hello indeed. It's very nice. And I might now go and, let's see, let's host a dinner. All right, so I'm going to host a dinner. I'm going to give it a creative name, a good description, contact information, and it's somewhere. It's beautiful. Oh, yellow screen of death. All right, so something's up with my container or my application code. Not sure what it is. There's like a big wall of yellow text. So what am I going to do? If I'm a developer, I go and I say, well, I want to debug this thing, right? I want to remote debug into this container. So let's do that. Now, turns out that the container image I showed you, or ran, I cheated a little bit. I actually ran a slightly different container. So I'm just going to go code dockerfile.debug. And I made one slight change to the container that I just, the Docker file I just showed you. And that was down the end here, these lines here. I went and grabbed the remote tools for Visual Studio 2015, downloaded it from Microsoft, put it into my container, and then ran the setup of that from the command line to put the remote debugger on the disk. So it's in the container. I also made sure I exposed the 2 ports that that one listens to, which is 4020 and 4021. And then I copied the Nerd Dinner files in. So at the moment, the image I'm running actually has the remote tools on it, but they're not running at the moment. One of the things I can do with Docker is there's a command called exec. So I can go docker exec and send a command to a container. This will effectively open up another process, another execution thing within the container, effectively another shell, and let me do something. So I want to start the remote debugging tools. They're not running at the moment. If I tried connecting to a remote container, it wouldn't be there. And the way I do that is, because it's kind of ugly in terms of getting the remote tools to run, I created a little batch script called start debugger, and I'm just going to send it the name of my container, which is, in this case, ND. So you can see the command there, docker exec, interactive, capture the terminal, and then the big long path to where msvsmon is sitting, which as you can see is an easy path. And then I'm going no status, silent, no auth, any user, no security warnings. So this is an unauthorized thing. Anyone use the remote debugger, by the way? You know, normally you have to run it and you've got the GUI and you've got to configure it to allow users and all that sort of thing. Or to run it as a service or all that sort of stuff. It's a pain in the butt, especially if you have authentication and you want to authorize people for accessing it. This is a way of running it. You can play around with the command line options. It does have a nicely unhelpful set of command line options. And you can read them and poke around with them and find one that works for you. This is now running. It's waiting for a connection. So if I jump over to Visual Studio now and I go debug and attach to process, I'll just zoom this up a little bit to make it a bit easier to see. I'm going to switch my transport to remote and find something. It's going to check my network and go, hey, I've found one. And you can see the machine name it found is D5B something, something, something. If I wasn't sure if that was the right container, I could go docker ps, which shows me my running processes. It is the one. I'm going to connect. I hit select. I've got show processes from all users on. So if I now come here, it's doing its thing. Give me all the users. Let's go. There it is. Excellent. And of course, being IIS, I need to attach to the W3 worker process. Attach that. Yes, please attach. I know I can do naughty things. And now I'll go back over to the application here, and I'll just jump back to the home, and we'll go host a dinner again, and I'll put in some bad data. And we'll hit create again. And dun dun dun, I'm now able to attach and debug into my existing .NET container, which is pretty cool, I think. So this now means I've got a way of doing remote debugging into containers running existing .NET code, and I can basically do all the normal development work I would expect to do as if it was on my physical dev box, which is sweet. I like this a lot. So whatever the problem is here, I think it's something to do with the fact that I've got an unlicensed Bing Maps and I didn't select the location properly, but you know, that's okay. It's a demo. All right. Let's leave that for the moment and switch back. Talk through a few other things. So I did say I was going to move fairly quickly. So let's talk about Linux. What happens with Linux containers? So we've got a few choices, especially in our ecosystem. We could take our existing code, port stuff to .NET Core, or maybe run it under Mono and run that in Linux. We might want to use different languages. Maybe we want to use Node.js. You could do that on Windows, obviously, as well. But maybe you just want to use some pre-existing images from that have been published by others. So for example, maybe you want to use Redis to do some caching, or you want to use RabbitMQ. You don't want to download all the dependencies. You don't want to put Erlang on your machine to run RabbitMQ. You don't want to have to set all that sort of stuff up. People have provided images that have all this ready to go. So I can simply grab these Linux-based containers, bring them down and build them and incorporate them into my application environment. And as I've mentioned before, Linux containers, because the maturity around the ecosystem around containers is a little bit more advanced than where Windows is at the moment, it's a lot easier to do some of this stuff in Linux land. Docker itself have put out a little sample app, and to save having to build one of these, I just went, you know what, I'll just use theirs. And this is a microservices voting application. What it consists of is a Python app that takes votes about whether someone prefers cats or dogs. It's a very exciting application. It's like simply click a button. Those votes get sent to a Redis cache, which is running the Redis image. That Redis cache gets polled by a .NET Worker container. That's .NET Core running. That .NET Core Worker process picks things up and puts the results into a PostgreSQL database, which is then polled every second or so by a Node.js application to show the results on a different port. So the voting app runs on port 5000, the result app runs on port 5001. You can play with this. There's a nice GitHub link there you can see, so you can poke around with this stuff and see how things work. There's also, you don't have to use PostgreSQL if you want. There's actually a Linux-based SQL Server image. So I could, if I want, rejig my .NET code so it's not using the PostgreSQL connections, it uses normal SQL connections, and I could talk to a different database server if I want. So let's see how this works. Jumping straight back into demo land. All right, so I'm just going to close Studio here. Yep, stop debugging, that's fine. And I'm going to switch down here over to Linux containers. So the way this works on Windows 10, this is the Docker app for Windows, is I'm running, it sets up a Moby Linux VM, and your containers run under a Hyper-V Linux virtual machine. Right, and if I go over here now, and I go to this one, here's my code. Oh, by the way, you'll have seen, once I killed everything, there it is. You can see that the connection dropped because the containers got killed. Once I switched from Windows containers to Linux ones, the kernel stopped, the host changed. And I'm going to go code docker compose.yaml. All right, so when we're setting up microservices and we're composing an application based off multiple containers, the way you do this is you generally use what's called a compose file, because I'm composing an application. And here we've got, as you can see, what we call services. Services are generally containers. So I have a service for voting, which uses a Docker file to build one up, and the Docker file and the context lives in the vote folder from my current directory. If I go down further, you can see there's a result service. Further down, there's a worker service. That's the .NET Core one. There's a Redis one, which instead of building off a Docker file, it actually uses a pre-existing image that we would pull down. And then I've got a database and so forth. And in fact, if I go over here now and do Docker images, you'll see I've got a whole lot more images under the Linux one than I did under the Windows one. You can also see the size of these things is quite different. There's no massive gigabyte images in here. The biggest one I've got is this 585 meg one there. Oh no, there's a 965, even better. There you go, SQL Server on Linux. Smaller than Nano Server, just about. That's ironic, isn't it? I talked about persistence earlier. If I had have stopped that container that I was running with the Nerd Dinner app and restarted it, my user login would have gone because I hadn't persisted it anywhere. I hadn't saved it. What Docker does, it has these things called volumes where you can map either folders from the host itself into the container as if it's part of it. So basically a union file system. I take this folder, I'm mounting it here in the container. Or I can create what's called Docker volumes, which are blobs, effectively, that get stored on the host that can then be put in there. So we see down here we've got a DB data volume, just a bit further down, DB data. And that will store things. So when my container runs and it's saving data, it's going into that volume, it's going to get persisted. In fact, if I go Docker volumes, volume ls, I have a number of volumes sitting here, some of which have just been auto-generated, but I also have my DB data one here, if you can see that, with my example app. How do I run this? This is fairly straightforward. I simply go docker compose up. And that's going to start everything up. Except my C drive's not shared. When did that happen? That's a bit rude. All right, one of the things you do have to do is you have to go into your settings when you do this and go to shared drives, and the C drive is shared. You lied. Let's just quickly do that. All right, and apply, and put in my password. Hopefully I actually entered that correctly. All right, now let's try that again. So this is so the Linux VM can talk to my local file system. It's just a Hyper-V thing. And I just want to see what's running. Okay, so I'm going to go docker compose, and I'm going to get rid of it. So I'll take that down. And I'll now go up again, make sure everything's good to go. The other way around. All right, that's up and running. If I go into a browser and I go to localhost 5000, there it is, there's my cats and dogs one. And if I go to localhost 5001, there's my results. And you can see historically, I've already had 5 votes because I've done this a couple of times before, as you probably would have guessed. And if I vote for dogs again because I like golden retrievers, you can see the vote changed again. Okay, so this is working on my local machine. But now what do I want to do? I want to be able to take this and I want to be able to deploy it to production. So let's talk very quickly about the ops perspective. What happens in operations? So if I'm going to deploy to production, the process is quite simple. I take my code, the developers write their stuff, they put their code together, they build it, they create an image, and they deploy it to a repository somewhere. Whether it's the public repository, probably not the best idea in the world, or a private repository, that's up to you. The ops team, if they want to then deploy to, say, production, they would pull an image from the repository onto one of their hosts in the production environment, and then they would do a Docker run from there. Azure, or Microsoft, has a container registry that you can use. It looks something like this. So I've created a resource group, and I've got a container registry, and it's backed by a storage account. This is as exciting as the UI is for this at this point in time. That's because I'm pointing at the wrong screen. Thank you for telling me that I don't know how to press buttons. Okay, container registry, this is the UI. It's exciting, isn't it? Not really. But just to prove that there's things happening in there, I can actually come in and explore. Ooh, zoom too far, possibly. Come on, let's go. Okay, if I look in my blobs, I do so love the portal. All right, so my blobs are here. There's a Docker blob. I'll just zoom that up, and you can see registry and v2 and repositories, and I've uploaded some images previously. So I have 4 images currently sitting in my repository on the Azure Container Repository, which is obviously in early days yet. It's definitely not finalized yet. So I might have a look at, say, the vote one, and there's layers in here, and what are the layers I've got? I've got the shards, and there they are, and all this sort of thing. So we can see what this has been built from, which is cool. If I go back to here and I go Docker images, you'll see some of these are actually sitting in here. I've got, just here, if I can make my thing work, there we go. Ignite 27, Azure Container Registry on Azure Container Registry IO. That's where they live. If I want to access those things, I simply use the Docker login command. And then after that, I can push and pull images from that repository. That's how security works. I won't go through it because it's not very exciting. It's just like doing a commit to a Git repository. Nothing to it. The nice thing, though, is if I then have ops stuff, I've got this middle point. So they can pull from that repository, devs can push to it, We can restrict it so only the build server can push images to it if they've gone through various QA checks and all that sort of thing. So you can play around with this to get your DevOps pipeline working quite well with containers. What I want to do, though, is I now want to deploy to Azure. So I've created over here, and I am jumping through a few things here, just in the purpose of showing you demos more than anything else. I'll do this one here. I've deployed Docker to Azure. If you go to docker.com, you can do this through the Azure portal as well. It uses an older version. I've gone down here and I've gone get started, or let's go get started. I click that button and it says, oh, what would you like to do? There was something up here that says Azure. I want to do the Azure one. And then I go deploy to Azure. It simply runs an ARM template. They've got an ARM template that does this stuff, and I jump in here and it will go and give me some options. I'm not going to do this at the moment because it does take a little while, because as you can see, it provisions quite a lot of stuff. It provisions storage accounts, IP addresses, load balancers, and I've provisioned what's called the Docker swarm. This is not just a single server running multiple containers. I've deployed a swarm here. I'm running 2 worker nodes and 1 manager, because that's probably enough for the demo. So 3 machines that are all going to run containers. And I'm going to use swarm mode, which is a peer-to-peer way of managing multiple containers in production to handle a few things. Why would I do this? Because, before we get too far ahead of myself, not everything is so simple. Production, you're generally going to want to run a lot of containers in the future at some point. So you'll have a lot of servers. How do you manage your load across those servers or across all those hosts? How do you distribute things? How do you manage storage? Where do you do containers? Where are they placed if you need to place them? Can I auto-scale? Can I have mechanisms to handle what happens when a container dies and restart it somewhere else? What do I do with my volumes? Can I upgrade the Docker engine without taking all the containers down and doing a manual upgrade? These are interesting challenges, and if they're not dealt with, Docker in production is never going to work, because enterprises are just going to go, no, we're not doing that. I need to be able to do 0 downtime deployments, regardless of what it is. With volumes, by the way, because volumes are stored on the host, what happens if we want to move a container to a new host? The volume's over here and it was on a path like C:/blob storage area. Or if I've got multiple containers needing to store that data somewhere else, share that image, or the storage, I should say. These are challenges you also need to deal with. You can obviously do things like putting the volumes on shared storage. So if you run a Samba share, for example, and point your volumes to that path so they get created on a shared drive somewhere, you can do that. Or you can use what's called a volume driver in Docker, and there's examples like Flocker, which gives you a distributed volume driver, so you can run these things across multiple hosts and get a nice distributed storage system, regardless of where the containers are running. There's all sorts of things happening in this place. This exists at the moment in more the Linux space. So I mentioned before, the environment is changing really rapidly around Docker, and most of the activity at this point is still in the Linux space, with Windows catching up over time. This is where orchestration tools come in. So I mentioned Docker Swarm. This is an orchestration tool provided by Docker itself. It's not the most mature tool in the world. If you want mature tools that your ops team are going to love, you probably want to be looking at something like Kubernetes or DCOS, which is Mesos, Mesosphere, Marathon. They're all the Apache ones. So Kubernetes is a Google project, and DCOS and the Mesos-based things come from Apache. They have slightly different themes around what they do, but they're all about managing containers across different hosts and making it easier for you to control placement and deal with shifting and moving stuff around and answering all those questions I mentioned before. To keep it simple, I'm just going to show you Swarm. Back on the right machine would be good. So this is a Swarm setup ready to go. What I want to do is actually deploy this thing. So This is Linux running in Azure. How do I get to that from Windows 10? Anyone know? Did you say putty? Yeah, you did. It's Linux land. You've got to set things up. You've got to create some stuff. It's okay. Once you've done the initial setup, it's not too bad. So now I'm on a Linux box running in Azure. This is the manager node. So if I go Docker PS, it's kind of weird. I see these Docker 4x Meta Azure. These are the containers that help run the swarm, which is interesting. What I really want to do is do Docker node ls, which lists the nodes in the swarm. So I can see I've got 3 nodes, 3 fingers, 3 nodes, 2 worker nodes and the manager one. I've already uploaded the compose file earlier. I want to do a deploy, so I'm going to go Docker deploy. Now this is deploying a stack. Remember I talked about bundles and stacks? I'm going to do Docker deploy of container files, Docker stack YAML, and I'm going to call this the vote stack. So you'll see here, this is a little more complex. The Docker file for this thing is a little more complex because it has information about placement and so forth and the number of things to run. And if I show you that very quickly, code, oops, I do this all the time now. I'm always doing ls and dir. Docker stack. You can see here I've got, from a deploy, I've got some extra information in here. What do we do for deploy? How many do we run? We run 2 replicas. They can run in parallel. Only run the database on the manager node, things like that. We've got more control over how this gets placed in production. And when it's running, sorry, I'll go to the right one. You can see I've got this here, and if I now go Docker node, Docker stack ls, I've got 1 stack running 6 services, and if I go Docker services, Docker service ls, I can see the services that are running, and I can see I've got the worker voter, and I've got 2 Redis instances, I've got 1 visualizer one, which I haven't shown you yet, 2 result ones, 1 database, etc., etc. And I can look more around what's happening here, but the deployment for this, as you can see, was really quite simple. I had a declarative file that said, this is what I want, just go compose that thing, run it up, get it running, we're sweet. And just to prove that it's all going, I'm going to jump over here, and I'm going to have, I haven't got a DNS name on this, by the way, but if I, whoops, wrong one, don't hit that, Richard. Don't say whoops publicly either. Say, yes, I meant to do that. Here's my IP address, 13.93.21.130, and I'll just copy that. All right, and then we'll go here, and I'll go IP address, port 5000. Feel free to do this yourselves if you want to type that IP address in. Do it on your phones, it's not a problem. Feel free to start voting. This is running, it's live in the cloud. Go nuts. And what I'll do just for fun is I'll bring up a different one and I'll go that address, port 5001, which is the result one. And hopefully we'll start seeing your votes coming in. There we go. People are voting. It's moving around. It's live. It's cool. We haven't had to do much. So we've taken our containers, we've written our little services, we've got our environment ready, we've proved that it works locally with single instances of the containers on my dev box, and then when we've gone to production, all we've done is added some information about how to deploy this thing and how to scale this thing out. So I've got a lot more flexibility. Look at you guys, crazy. Oh, that's better. Less cats, keep going. Okay, where are the cat people? There is one other app that's on this particular one, which is the visualizer. So if I go to port 8080, what we have here is a nice little tool that just shows me what's actually running on the swarm as well. So this, you can query the swarm through the API. You can find out information that's going. I didn't write any of this. I'd like to take the credit for it and say that I wrote it all in my spare time. I don't have that much spare time. But I can see, here's 2 instances of the vote container, the results over here, the database is here, and I can see what's going on. If I wanted, I could kill things, whatever else. And just finally, to prove that things are working, you guys still voting? Yeah, you are. I can see you updating in the background. If I go docker stack rm vote, I've just nuked that. Anyone who's trying to vote now, you should find that you get the there's no site. It's gone, because I just killed it, which is cool. Switching back. All right, so these are orchestration tools. That's the simplest orchestration tool. It's provided by Docker itself. Kubernetes and DCOS are a fair bit more complex. They've got much better management UIs, much better dashboards, a lot more features. They're worth having a look at. Feel free to play around with them is probably the best way to talk about that one. So Kubernetes, DCOS, etc. So just to recap where we're at before I open it up to questions, we've gone through Docker basics. Hopefully I've given you some perspective on the IT and the dev side of the equation, shown you how we can take existing .NET code, put it into Windows containers and run it today without too much drama at all. Gone through heterogeneous code, running different languages and different environments and mixing things. I should mention, by the way, with Swarm, you can run mixed containers, mixed hosts. So you can have a Swarm that comprises of Windows hosts and Linux hosts. So if I wrote some .NET framework code that wanted to talk to a Redis server, I could run a Linux host in the Swarm and a Windows one and run my Nerd Dinner app talking to SQL Server running on Linux or using Redis caching or whatever else. We can do that today. Talked about the difference between Windows and Linux containers, talked about container orchestration, given you hopefully enough of a taste of where things are at and what to think about in terms of your environment for the future, especially if you haven't really done much kicking of the tires yet. That's where we're at. We're pretty much done for time. We'll look at that, almost spot on an hour, which is great so that you guys are able to ask me lots of questions. Don't forget to keep going with your learning path. Make sure you do lots of your evals, Spark After Dark tomorrow night, play with drones, whatever else. It'll be fun. So, questions, guys? Yeah, we'll start here. Yes. Okay, so the question is that 10 gig Windows Server core, what's the licensing for that? I would like to tell you I'm a great Microsoft licensing person. I'd like to tell you that, but I'm not. So you've got to run it on a Windows Server host, obviously, because of that kernel virtualization. So you're paying for a license for that. It depends a little bit on the way you run. So Windows containers can run as Hyper-V containers or as normal, I suppose, normal straight-up containers. The licensing depends a little bit on your OS version, how many of them you can run. You don't have to license the container itself because you're virtualizing the operating system. The limit I saw this morning, who was in the Windows container session this morning with Ben? So he talked about the licensing briefly in that one and mentioned that, which edition was it? Standard or something, can run 2 Hyper-V containers at once, unlimited normals, and then the enterprise can run unlimited both. Windows 10, I don't know. I haven't actually checked how many I can run. Question behind you. Yep. Patching the OS. Don't. If you want to patch the OS, what you do is you grab the latest version of the base image, Windows Server Core, and rebuild. Because Microsoft's constantly releasing this. In fact, they released one this morning, I'm pretty sure. Let me switch across very quickly. Okay, so if I go to hub.docker.com, just to show you, and we go here and we search for Windows Server Core. All right, there it is. Last updated, where is it? 6 hours ago. Microsoft's constantly pushing this base image. Each time they're pushing it and they're patching it, the image is growing a little bit. 12 months ago, I think the image was about 8.5 gig-ish, something like that. Obviously, they've matured it a little bit since then, but each time they're patching it, obviously it gets just that little bit bigger depending on what the patch is. So if I want to patch my containers, remember, I don't maintain containers. You've got to change your thinking. What I do is I replace them. I take the existing container, I shoot it in the head, kick it, it's gone, and I simply run another instance. So I create a new image with the patched base OS. So every time they release one of these, I just run my Docker file again, rebuild my container images, push it to the repository, and redeploy it into my new host. Do I have control over which version? On the base image, no. They haven't released multiple things. So you see here, actually, let's just check tags. I'm pretty sure they won't, but look at that. There's a few. Not sure what those tags are. ASP.NET's probably a more interesting one in terms of versioning. So if I look at ASP.NET, do I hit enter? Yes. There we go. They actually say we've got supported tags. So 4.6.2, 3.5, and you can see there's various tags. Latest will always point to one of those tags, but they've got other ones. So you can choose based on the tag what you're doing. So if you remember the Docker file that I showed with the Nerd Dinner one, I wanted to start with the 4.6.2 one, which is 1, 2, 3, third in the list just before latest up there. If they revved that and they did a 4.7 or a V5 or something like that down the track, I could still use that 4.6.2 one and pull that from the hub. So that means I've got some stability in what I'm doing. I can always, if I really want, pull down an image, tag it myself locally, or tag it into my own thing. Because really all I'm doing is I'm taking a layered snapshot. I just tag that and give it my own name. So this is the Richard version or the snapshot or whatever else, as at 15th of February 2017. Question up there. What terminal program am I using? This is console 2. Actually, I'll go back out. You're talking about this one here, the multi-tabbed interface one. Console 2, there's plenty of others floating around that do tabbed interfaces. Putty's a great one. I like it because I can play around with different colors and all that sort of thing, and it's nice. Question over here, I'll go this side.
You're running applications with databases.
Yep.
And you've got the databases in containers as well. Can you have a container connect to a standard database farm, or is there a reason that
Okay, so
you're containerizing the database as well as the application?
So the question is, I showed you a database running in a container. Can I take other containers and just point straight to a database server running somewhere else, like a normal VM, physical SQL database kind of thing? Absolutely, no problem at all. It's just a network call, right? So there's no reason not to do that. The reason we try and do the container deployment of a database is because logically, the database is part of the application. So if I'm containerizing the app, containerize the data that goes with it, because containers are all about the application and the environment. If I do that, it means I don't have to worry so much about the ops team saying, no, you can't touch my pristine database ever, like ever. You don't no data in it either, because that will mess with the number of CPU cycles it's consuming. And then I'll have to back it up. But it's the thing. So I want to treat an application as a logical whole, a composition of multiple containers. Question down the front. Is it possible to control a host name the container uses when it's running? I don't know, possibly, don't care. I shouldn't care. That's the whole point. Containers are immutable and replaceable. If I run a new instance and I run multiple of those instances, like I did when I did the Compose, then I was running the voting app and I had multiple accounts, I don't want both containers to have the same name. And the name doesn't really, well, I don't know the use case, but machine whitelists from the host or from the container, because the container is not a machine. Don't think of a container. Okay. Yes, that's the container ID. The host name's automatically the container ID. You need to think slightly differently. Possibly, because you can also do NAT translation out from the box if you're doing IP whitelisting instead. It's the... Okay. I don't know. I haven't tried that one. What are you whitelisting to, just out of curiosity? Okay. Okay. So you're going to effectively an external service that's using sensitive information, and you want to make sure you don't get yeah. Yeah. Another question. Yep. That's the orchestration engine. So orchestrate, not so much in Swarm, you don't have that much control. But the Kubernetes DCOSs, I think Red Hat's got something around the container space as well. I'm trying to remember, OpenShift or something, I think. These things will help you put limits on containers and then monitor them. And that's why I say, just from an orchestration perspective, have a look at the docs that they all talk about and provide, because they all have reasonable documentation, and play around with some. It doesn't cost much to set these things up, because they're generally open source or freely downloadable. So you can experiment a little bit. Another question over here. There you can. So that's the container naming? Yep. That one. Oh, okay. Yep. Other questions? Let's go on the bride side. Anything over here? I'm trying to see. No? Okay, we'll go back over here. Anything else? Yep. Am I aware of any in-production Windows Server 2016 containers in Australia? No. It doesn't mean they're not done, I'm just not aware of them. Most people that I'm coming across, at least here, are still very much kicking the tires. I know there's Linux ones in production. There's a company in Canberra that runs Cassandra as a service using containers. We talked about it at Ignite last year. There's a session on it. So if you go to last year's Ignite, you can see it's all about how do we Dockerize Cassandra and run it and make it commercially supportable and all that sort of stuff. That happens. Windows side, not aware. Yep. You have two boxes. So the question was, when I switched from Windows containers on my dev machine to Linux containers, everything died. It died because I killed the host. Because there's only one Docker engine running at a time. The Docker client can talk to any Docker engine. So if I wanted, I could run a little Linux box with the Docker engine on it separately, and I could deploy to that and have my local machine for the Windows containers and some cheap Linux box running host, running the service there, and I could just push stuff to it. Can I run Docker in a Docker container? Okay. So there's this movie called Inception. If you watch it, that should give you the answer. Spin that top. Yeah. 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 So the main issue is the kernel virtualization, virtualizing on top of itself. And there's a few little technical limitations. I would expect at some point someone figures out a use case where that's worthwhile, and then they'll find that there's a patch made somewhere and it works at some point, but seriously. Question up here. The Windows subsystem for Linux, you can't run Docker in that. The Docker client, you can't run the Docker host, because the main reason is the Windows subsystem for Linux runs in user mode, so you don't get the kernel and you don't therefore get the virtualization. But you can definitely run the client there. You can't install it from the Docker site directly because they don't give you just a client-only install. You have to grab the source and build it. Question up there. The question is, does Windows have anything to run Nano Server as a container service at the moment? Yeah. Oh, the container registry is just a registry. I can put Windows containers in it and Linux containers in it. It's just it's a file system effectively. Run Windows Server 2016 and run it on that at this point in time. I would expect that the Azure Container Service will get an update at some point so that you can choose between your hosts. At the moment, when you deploy it, it basically just deploys Linux hosts at this point in time. But I don't work for the product team. I don't even work for Microsoft. So I can't say too much on that. More questions? I saw another hand somewhere at some point, but, oh. Any other operating systems? I've tried the Xbox. No, I haven't. No, are there other operating systems? Mac, by the way, if you're running Mac, you can get the Docker app for Mac and do the same sort of thing on that. You can't run Windows containers on the Mac, I think, unless you've installed Parallel. I don't have a Mac, so I haven't tried it, but I don't think you can. Yeah. Yep. 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 So the questions around configuration in environments. When you do Docker run, you can pass parameters to the container. So the Docker run command, you set things up, and then you give the container name, and at the end are basically just parameters that get passed to the container. So when you start, you have what's called an entry point. You can have those come through it to the container at that point, and then do what you want with it. You can also use environment variables. So you can pass environment variables to the container to pick information up off that as well. So you might say this container, the environment is prod, so I'll pick that up and I'll use that and change the way I'll work slightly. So definitely doable. Other than that, I think we'll probably call it quits at that point. If you want to ask more questions, please come and talk to me. Thank you very much for coming. Enjoy the rest of Ignite, and we'll talk soon.